going to talk about inverses today. What does it mean to be a mathematical inverse? Complete opposite. So if I had the number 4, what is 4's inverse? Well, you need more information than that. There are lots of different types of inverses. So, how about 4's additive? Negative 4 is positive 4's additive inverse. So if I combine 4 and its inverse, which is negative 4, I get what? 0. What is the significance of 0 as far as addition is concerned? Zero is a very special number with addition. Zero is referred to as the identity. And in mathematics, the identity is essentially the do-nothing element. So some of you in here are Emory High's identity. Okay, so let me, I'm going to explain a little more how identities and inverses work. If you want to know what the identity of a set is, you combine any element with its inverse and you get the identity. Or if you take any element and you combine it with the identity, what are you going to get? The original element. Now, this doesn't seem very important to you, but all of algebra and essentially all of addition and multiplication in all mathematics with numbers relies on this fact of inverses and identities. Now, if you go on and you take abstract algebra, you'll learn more about this, but most of you won't. So essentially, here's what happens. If you have some element A, and you combine it using whatever operation you want, so some operation here, and you combine it with A inverse, whatever goes in that box, raise it to the second power, addition, subtraction, multiplication, anything, you are going to get the identity. And likewise, if you take any element and you combine it with its identity, you are going to get the original element. Okay? So, if I had 4 times, what is the inverse for multiplication of 4? 1/4. And if I multiply 4 and 1/4 together, I get 1, which happens to be the multiplicative identity, because 4 times 1 equals 4. Now we could do the same thing with subtraction. We could do the same thing with division. Right? We can also do inverse operations. If I had 4 to the second, what is the inverse of squaring something? Square rooting. So that would be the inverse. Okay? With functions, how do you invert a function? Let's say I had y equals 2x plus 1. How do you invert that? Well, in a function, you have a list of domains and a list of ranges, and you draw lines between them. Right? So if I plug in 0, so 0 if we plug in gets turned into 1. 1 if we plug it in, you would get 2 plus 1 is 3. 2 if we plug it in, we get 5. 3 if we plug it in, we get 7, and so on. So the inverse is just going to do the exact opposite. It's going to turn 1 into 0, or no, yeah, it's going to turn 1 into 0, 3 into 1, 2 into 5, and 7 into 3. Whoa, I got that backwards. That row's wrong. 5 into 2, and 7 into 3. So essentially, all we did was took this group and moved it over here, and took that group and moved it over there. And graphically, we've talked about this before, if this is 2x plus 1, if we take that 45-degree line, then the new graph is just going to be reflected across that, so it would look something like that. So how do we change the function algebraically? We just switch the x and the y. So I'm going to turn this into x and turn this into y. And I get x equals 2y plus 1, but we want this in y equals form. So I'm going to subtract 1. So I get x minus 1, and then I divide by 2. And now it should do the exact opposite from what we had before. So if I plug in 1, I should get 0. 1 minus 1 is 0 over 2 is 0. If I plug in 3, I should get 1. 3 minus 1 is 2, and 2 divided by 2 is 1. If you plug in 5, 5 minus 1 is 4. 4 divided by 2 is 2. And we have completed the inverse. Okay? So, if you take f of x and its inverse, f inverse of x, if we combine those two functions, I should get the identity, right? I should get the 0, the do nothing. So as far as multiplication is concerned, 1 is nothing, because 1 doesn't do anything in multiplication. As far as addition is concerned, 0 is nothing. That is the identity. So if I take f of f inverse of x, also known as f of f inverse of x, if I plug one function into the other, I should get the identity function. But the question is, what function does nothing? Is there a function out there that doesn't change anything? Well, it's the function where if you plug in 3, you should get out 3. If you plug in 7, you should get out 7. So the function is y equals x, which happens to be this line right here. Oh, imagine that. So when you invert stuff, so if I had a parabola and I went to invert it, it's going to be a reflection across that line. But there are some numbers that don't move. This one doesn't move, and this one doesn't move. And the new graph looks like this. So that 45-degree line, that is the reflection line, because any point on that line isn't going to change, because the function is y equals x. So if you take one function and you plug it into the other function, and the resulting function is the identity, what does that tell you about the two functions you're looking at? They're inverses from each other. And that's all that's happening in this. So we're doing 204, 51 to 59 odd. So I'm going to do number 52. So it says, show that f of g of x equals x and g of f of x equals x. So what it's saying is these two functions are inverses. Show that they are inverses by composing them and getting the identity. And you have to do it both ways. So number 52. So f of g of x. I'm going to plug g of x in here. So 3x plus 2 minus 2 over 3. Those cancel, and that cancels, and I'm left with x. Are they inverses? Yes, because I composed them and I got the identity. So the other way, g of f of x, I'm going to stick this stuff in here. So 3x minus 6 over 3 plus 2. Okay, can I pull anything out of the top of the first fraction? A 3. So essentially, I can get rid of this 3 and that 3 and turn that into a 2. And I'm left with x minus 2 plus 2, and that turns into x. Okay? All right, look at 54. So I'm going to stick this in here. 2 minus the square root of 2 minus x squared. But the square root and the square cancel. So 2 minus 2, well, it's 2 minus x, right? So I need to distribute the negative. 2's cancel, and I'm left with x. And the other way, if I plug this in here, let's see that a little bit better. The square root of 2 minus 2 minus x squared. Distribute the negative. 2 minus 2 is 0, and I get the square root of x squared, which is x. Easy enough, right? Okay. Good luck.